Hi, it's Mr. T here. In this series of videos, I'm going to go through how to answer exam questions so that you get the best out of your writing when you're sitting exams. If you find this video useful, don't forget to click a thumbs up, subscribe, and then click that bell for notification if you want to see the next video. Hi, in this video, I'm going to be looking at the NCEA Organic Chemistry papers, the Level 2 from 2021, 2022 and 2023. I've taken the questions out of that paper about how bromine water can be used to distinguish between unknown compounds, and I go over how to answer these questions in a way that will get you a really good mark. So I hope this is helpful, and yep, I'll leave it at that. Right, so if we're going to talk about Markovnikov's rule, the first thing we have to do is identify what is an asymmetric and what are symmetric alkenes. So alkenes that have the double bond in the center of the molecule are symmetrical. So this molecule on the right here, this is butyrene. So if I rotate this molecule around, it will 180 degrees, it will look exactly the same. It's kind of a mirror image across the center. So if we look at the double bond here between these two carbons, on the right hand side we have a CH3, and on the left hand side we have one CH3. That makes this symmetrical, and that's important for the next part of what I'm going to talk about. Alkenes that don't have their double bond in the middle are asymmetric. Now, what do I mean by asymmetric? So here is a picture of an asymmetric molecule. Now, if you think about this, if you think I was adding, let's say, hydrogen bromide to the first one, I could add the hydrogen off the first carbon and the bromine off the second carbon. Or I could add the bromine off the first carbon and the hydrogen off the second. No matter which way I added these, all I would need to do is rotate 180 degrees to make it the same as the other. So I get exactly the same product. When we look at an asymmetric molecule, I could either add the bromine off the first carbon or the second carbon. And depending on where I add it, would make a completely different molecule for my actual product that's produced. Another thing that we might notice is that if we actually put a point in the middle of the double bond and rotate this one 180 degrees, what you'll notice is it doesn't actually transpose back onto the original, and that's because it's not symmetrical. So we have molecules that are symmetric and molecules that are asymmetric. Molecules that are asymmetric are we are going to have to use Markovnikov's rule to identify whether what side the hydrogen is going to attach to and what side the the halogen is going to attach to. So when the HCl is added to a symmetric, let's have a look at this. Here is a symmetric alkene. We can either add the hydrogen to the left of the carbon of the double bond, or we can add the hydrogen to the right of the carbon of the double bond, and we add the chlorine to the respective other side. Notice that these two molecules here look different as they are drawn, but if I rotate the one on the right 180 degrees, if you can do that in your mind, it will be exactly the same as this. And we know they're exactly the same because they have exactly the same name, 2-chlorobutane. 2-chlorobutane. So a symmetrical alkene, when we add hydrochloric acid to it, HCl or HBr or H2O, will produce just one product if we have a symmetrical one. If we have an asymmetric, we get two possible products. So here is our asymmetric molecule. We can see here that we can add the chlorine to the second carbon, and then we would get the product of 2-chlorobutane, or we can add it to the first carbon, and we would have the product of 1-chlorobutane. So when we add this HCl, or we add the reagent that has two different things that are going to join to the double bond, we will get two different products if our molecule is asymmetric. So, Markovnikov's rule is a general rule that we use to work out which of these products will happen more often. In any chemical reaction that we carry out, there are thousands, if not millions, of molecules that are reacting at one time. When we talk about what is the major product is, we think that if we took 1,000 reactions, the major product would be the one that would be formed 700 times, compared to the minor product would be the one that's formed 300 times. So it's all about statistics. Which one is more likely to form? Actually, both options will happen, but one will happen more of the time because it's easier for it to happen that way. Now, Markovnikov's rule, it has just a wee thing for us to remember it by. It's called the rich get richer. Now, what they mean by that is a carbon is rich if it has hydrogens directly attached to it. So the carbon with the most hydrogen atoms bonded to it gets the new hydrogen bonded to it. So the carbon that has the most initially gets the new hydrogen, and the halogen, or the OH if it's water, attaches to the other carbon. Let's have a look at an example of this. So here I have two carbons, the red one and the blue one. We can see that the red one is the rich carbon because it has two hydrogens attached. It has two hydrogens. And the blue one is the poor carbon. So the red one, when I add H2O or H and OH to it, is going to be the one that attracts the extra hydrogen the majority of the time. Notice here I've said it's 80% for this reaction. So this is the product the majority of the time, the one where the hydrogen joins to the carbon that had the most hydrogens for a start. And remember, we're only looking at the two carbons that are part of the double bond, and we're only looking to the hydrogens that are directly bonded to the carbon. The minority of the time, the hydrogen goes to the poor one. And that's Markovnikov's rule. And remember, we remember this by saying the rich get richer. However, when we explain it, we have to use this phrase below. The carbon with the most hydrogen bonds bonded to it gets the new hydrogen bonded to it. We don't write the rich get richer, we just use that to remind us what happens. Let's look at an example from an example. Okay, so in this example, they've given us two compounds, compound 1 and compound 3. It says, analyze the reactions of compound 1 with hydrogen bromide, HBr. In your answer, you should state the type of reaction occurring and justify your choice. Okay, so the type of reaction that's going to happen here in compound 1 and compound 2 is an addition reaction. We know an addition reaction, the double bond breaks, and two new atoms are being added. In this case, a hydrogen and a bromine. We can see in this case, because there are two different atoms being added, there is the possibility that we might have to use Markovnikov's rule to identify the major and minor. Let's look at compound 1. In compound 1, we can see that the double bond is not in the center and is not symmetrical. It's at the left, and one side of the double bond has a big ethyl group attached, and the other side has a hydrogen. It's asymmetric. So we would explain here that compound 1, there are two products because the alkene is asymmetric. So there are two unique positions that H and Br can be added. So it can be added to the first carbon or to the second carbon. So there are two possible products. The carbon with a double bond with the most hydrogens attached is the one that will form the hydrogen atom for the major product. Okay, so that's us stating Markovnikov's rule, not saying the rich get richer, but saying the carbon with the most hydrogens gains the hydrogen the majority of the time. Since C1 is the carbon with the most hydrogens, noted we've said that this is carbon 1. I can annotate this by putting a wee 1 up here and a wee 2 here. Has two hydrogens, and C2 only has one. C1 gains the hydrogen, and that means that C2 gains the bromine, and we form bromobutane. This is bromobutane here I've drawn it because it said they want me to give the structural formula of all products. Okay, so what is the minor product then? Well, the minor product is actually when the hydrogen goes to C2 and the bromine goes to C1. So the opposite of the rule. And it looks like this. So this is why we get two products, a major product and a minor product. Now if we draw out these molecules, it might be good to write major and minor. Major above and minor below this one. So what happens with compound 3? Let's have a look at that. So we can see the double bond is right in the center. And if we number from the left, this carbon is number 3, and if we from the right, this is number 3, and from the left, this is number 3. So actually, both positions are carbon number 3. So for compound 3, there is only one product because the alkene is symmetrical. This means that only 3 bromohexane can be produced. So if I put a hydrogen off this one and a bromine off that one, it will be 3 bromo. If I put a bromine off this one and a hydrogen off that one, it's still going to be 3 bromo. It's going to look just like this, 3 bromohexane. Okay, so this is quite an in-depth question, and it has quite a lot of marks that you can gain from this. So you can you get a mark for identifying the type of reaction, addition, so that should be straightforward. If you can identify that compound 1 forms 2 products and one product for compound 3 forms 1, that's another achieved mark. If you can explain what an addition reaction is, that's this first sentence, that it is the breaking of the double bond and 2 new atoms or substituents are added to the place where it break, that's a merit. If you can explain with limited detail that there are 2 products, or correctly draw and identify the structure of the major and minor. So if you can identify what the major and minor is, that's a merit as well. So explain what the addition reaction is, but if you can actually identify which ones are major and minor. So to get the achieve, you just say, look, there are 2 possible products. To get merit, you have to say there are 2 possible, draw them or name them and say which one is the major and which one is the minor. And to get the excellence, well, you have to do all of this. The last part. Often people will forget the last part and not say, oh, well, compound 3, it doesn't form 2 products. But actually, they want you to say it does form a product, and it's the same product every time. And look, that's Markovnikov's rule. And if you practice this, what I've put here, just download the exam from NCEA. Use the numbers I've got at the top at the right there, and look, this will help you out a lot towards doing very well in your exam.
Okay, if you've got to this part of the video, you've obviously watched all the examples that I had on those 3 questions. Hopefully this has fortified your understanding of geometric isomers, and you are now well prepared to go and attack that exam. Good luck, and if you found this video useful, don't forget to like it, subscribe, and look out for new videos that I might put up by clicking that bell. See you later.